Hello, everyone. I'm Thomas Potter, AI researcher and expert since 20 years. And I would like to give you an overview of what I think the next level of AI is probably about. So this is around the ideas and suggestions that have been presented around OpenAI's Qualia Q-star system. And I want to give a presentation on how minimizing AI's hallucinations, or also called confabulations, is possible, and the path towards artificial general intelligence with examples, hypotheses around LLMs and what Qualia Q-star could be. So these are the topics I plan to present. Basically pretty much all promising directions in AI nowadays. I'm Thomas Potter. I have AI experience since 1992, did my studies and master's thesis at the German Research Center for Artificial Intelligence, was the only one who finished in AI around the year 2000 in entire Germany. So with all this master and project work. I did many AI projects, was in 3 autonomous driving programs, in AI for open source SOC systems, security operations centers, in AI ML architect in many projects, for example, for global retailers, e-commerce, bank, AI-based marketing, analyzing financial transactions for fraud, money laundering, and so on, intelligent chatbots, corporate memory, AI-based market research, predictive maintenance, and so on. And you can contact me as this is tp@compre.com. So the key criticisms of current AI training capabilities and directions is that even in 2024, LLMs still do only predict the next token. That's a big weakness. And even with supervised and parameter efficient fine-tuning, SFT or PEFT, that still requires terabytes to petabytes of high quality labeled training data to avoid catastrophic forgetting. Also, low rank adaptation, retrieval augmented generation, and other techniques have serious drawbacks. And the value created by various AI model use cases is typically far lower than the training and operating costs. So for classical corporations, it typically costs a few million US dollars to complete an AI project. And that's too risky for many of them. Thus, we need better approaches and algorithms. Another surprising critic maybe is that ChatGPT and related LLMs are set up in related ways to a psychics con. So the audience selects itself. Also on both sides, the scene is set. Then narrowing down the demographic here for the LLM, the prompt establishes the context. The market is tested. Here the marks test themselves. There we have a subjective validation loop. Here for LLMs also. And in the end, people believe, oh, that psychic is the real thing. Or for the chatbot, well, the chatbot thinks has sparks of general intelligence. And so that was the presumption and is actually turning out a little bit like that. So it's so therefore the purpose of this presentation is to show where AI is going and which investments are most likely to succeed, especially since OpenAI has probably indirectly killed thousands of specialized AI startups and initiatives because of its more general nature. Before that, one couldn't even get a general AI funded because it was said that only specialty AI have a chance. And ethics was just focused on ethics for symbolic AI. And now we have sub-symbolic AI. So ethics principles cannot be directly applied. And ethics has to be reinvented, as it seems. So we're trying to give a completely new guidance with this presentation in which directions AI could be going, especially with the various new frameworks. So the AI tech landscape is very diverse. We have the EU AI Act with these elements. We have these domains of the AI Act: data, compute, model, and deployment. And we have low compliance levels from 5 out of 48 points to 36 out of 48 points. Not very good in general. So these are the priorities for our research of the US National Security Commission. So advanced scene understanding, AI system risk assessment, and so on. We have common jobs that are being created in the AI field. Mark Zuckerberg bets billions on AGI. The sales of H100 NVIDIA GPUs is exploding, as we can see here, with Microsoft and Meta being the main customers, and actually Tesla with 15K being a relatively small customer. We have 7 stages of AI towards AGI, and here they are in more detail. And we have in some domains AI improving human baseline performance, as you can see, above 100%. And that's in some specialty domains like image classification, visual common sense reasoning, natural language inference, and so on. However, only specialty domains and at gigantic costs. That's the issue. So here are the 6 principles of AI: capabilities over process. This is generality and performance, and so on. Here are some introductory, less deep or technical presentations. I'm focusing mainly on the technical details. And now to the heart of it, the possible leaks, speculation, and possible path towards AGI minimizing hallucinations. So it started with Sam Altman's dismissal and his letter to the board, and the first leak around this Qualia system having demonstrated an ability to statistically significantly improve the way in which it selects optimal action selection policies in different deep Q networks, exhibiting metacognition. And then also that it did a ciphertext only attack on advanced encryption standard 192, which we use in HTTPS, SMIME, and most internet secured standards. So that is the basis for a big cybersecurity attack and big security breaches. So here are details about it. So it seems to have continued with results from Project Tundra using tau analysis techniques and crypto analysis books. And as a consequence, AES is probably not sufficient anymore. And we are risking an AI arms race, or multiple arms races around AI, and then around cybersecurity, and maybe around molecular sciences, creating toxins, and various other things. That's leak 2 as text, where they say that the system can self-modify and runs, for example, up to 78 million checks in 4 seconds on a big cluster, I presume. And that's a recursive self-optimization process leveraging heuristic algorithms to exploit latent synergies within its subroutines. So it used metacognitive strategies. No one of the human employees did it. So so a lot is going to change in 2 months. The leak source said, God help us, it's praying basically. Especially if a self-modifying AI gets into the wild and then cannot be controlled anymore. That's a real risk. Then another leak talks about mainly energy-based models, EBMs. So that's a comprehensive leak. Having ChatGPT simplify basically its own leak, probably. It says, yeah, it's these EBMs, thinking in abstract, finding the best thought, turning thoughts into words, training to get better. And it's cool because they could lead to more thoughtful and relevant conversations with the AI, much like talking to a person who really thinks before they speak. So Q star takes a moment to think and to calculate before giving you the best possible answer. Then there's some other leaks. For example, you don't get superhuman performance by doing better imitation learning on human data. And it could be about AI self-play and reasoning in games like Power and Diplomacy. So, or AlphaGo-like techniques. So the leaks seem to be valid. So how it fits in. So, and even if it might not be perfectly valid, we should not ignore it. We should always ask what ifs. So what if this is true? What if AI does self-optimize and then gets into the wild? What if it cuts the human developers out of the loop? How many unemployed people would that leave? What if AI doesn't care? What if evolutionary universal principles can be seen in a similar fashion in an electromechanical tech ecosystem, so meaning that it evolves by itself possibly? What if artificial general intelligence or super intelligence is here, nobody has noticed it yet? What if big tech discovers AGI and lacking any current reporting requirements doesn't inform the government or us? What if big tech or lab managers cover it up? So many questions to ponder. So this could be such an important discovery that we should not ignore it. Then there's also some disinformation campaigns which validated even more that it could be right. And OpenAI could also be building upon poker strategies like Nash equilibrium or game theory optimally. Yeah, then an initial analysis has proposed these 13 techniques essentially that this Qualia Q-star system is at the core a large language model like ChatGPT and reinforcement learning, and on its path towards AGI, ASI, based on these elements, everything of thought, reasoning, so something to search over, process reward models, ranking all the steps of reasoning, GPT-4 to score all vertices of the tree, with reinforcement learning with AI feedback. So GPT-4 being the AI that gives feedback, Q-learning to optimize this, reinforcement learning, policy neural networks, value neural networks, maybe a 3D model or a metaverse information plus real-world information, and maybe emotion or pain information, because that's how we learned as babies and children. Then maybe search over strategies, options, or plans. Math, logic, and ground truth, synthetic training data, because the big players seem to have already scraped all the high-quality data in the world. Model transfers, pruning, and adaptation, graph convolutional networks, in short, ConvNets, maybe reprogramming itself, which is dangerous, and energy-based models. Now, in categories like this, agent level and outside, reinforcement level, graph semantics level, learning and training types, neuronal level, prompting level, assessment, and parsing. So now to the details of these techniques. Metamorphic AI is an AI with transformation targets and self-reprogramming. So it's about an input space, perturbations, and a perturbed input, like when you have typos, synonyms, or blurring in videos. Then the ML model transfers this to the output space, and you would also have a bad result from a blurred image. So these techniques are around improving the results. For example, with GANs, temporal logical modal relationships, and so on. And for example, building a knowledge model for programming to understand really what one is programming, not just predicting the next token, as an example. Then we have these process reward models. Classically, we had outcome supervised reward models, or ORMs. They only judge the output at the end. And these process supervised reward models, PRMs, they look at each state or at least each interesting state and score that state, and possibly even the moves or the action possibilities. So this switching from a sparse reward to a dense reward. function in that way. And visually, you see here there's in red a wrong or not useful mathematical conclusion, and that is identified and then eliminated. And with self-assessment, you see the red face here for things that are incorrect. There are many papers around this, PRMs and math. Another element is Monte Carlo tree search, MCTS, policy neural networks, value neural networks. There are some details on this and a ground truth signal to not fall victim to fake news or to theories. Probably some deep reinforcement learning with self-play and look-ahead planning. So self-play is the idea that an agent can improve its gameplay by playing against slightly different versions of itself. And look-ahead planning is the idea of using a model of the world to reason into the future and produce better actions. So it started with chess computers, for example, which were planning 7, 10, 20 steps in the future. And now this has been generalized, these strategies that have probably started with chess. Another idea is to bring creativity into these systems, for example, with the transfer of principles or ideas. The idea is that our human creativity is not that unique in the end. So we can be experimenting, observing phenomena, analyzing, testing, have explanation attempts, critique, and deep understanding. And we can transfer these and other concepts, ideas, rules, and constraints from one domain to another, considering domain knowledge, heuristics, and so on. So we can look at the space of what is possible, what's needed, and what are promising avenues, and test out the most promising action options. Then we have planning and analyzing of constraints and working around them, data science and pattern detection. And this can be combined to come to relatively creative outputs. Then theory of mind is important. It refers to the cognitive capacity to attribute mental states to self and others and build mental models, or also called common sense psychology or mind reading, mentalizing, and so on. It acts as a mental compass and helps with social interactions around us. So the problem is the continuous adjustment of knowledge, insights, and rules that's necessary to really understand other people and keep understanding them. They are also probably key to achieving AGI ASI. And ChatGPT 3.5 was assessed to have the theory of mind of a 9-year-old, which is already relatively good. So from there, from theory of mind, we can go to human emotions, intention recognition, analysis and translation, and speech and body language. And they are often interwoven. Then, for example, we have appearance, like appearing nervous, getting a red face, sweating, or not being comfortable. And they are all related to body language and other elements. So it's important for the AI to understand this. So theory of mind can infer the objectives of entities, like humans, animals, and so on. And robots understand the importance of their awareness and the different consequences it could lead to, communicate with human beings better, explain decisions in various languages, and help the user or other robots to understand and able to understand the intention of humans or other similar robots. So from easy to complex in theory of mind, it's to understand wanting, then thinking, then seeing, leads to knowing. To see that seeing leads to knowing. Understanding false belief, understanding hidden feelings is most difficult. In the end, we want to have full AI models for human emotions and psychology, psychiatry. Very promising is the synergistic integration of probabilistic knowledge graphs and graph neural networks. So these are basically two variants of the same thing, where these knowledge graphs are deeper semantically, typically but they can also be the same or be slight variants of each other, and integrating that with large language models. So the key ideas here, these four are illustrated in the following diagrams, which is that we can have here a text graph and then a knowledge graph and entity sequence. So this is on the syntax level, this is already on the semantics level. This entity sequence, they can both feed into large language model, and we can have a mask-based approach. As we see later, mask-based approaches are also not ideal. There are better solutions now. So then we have a fusion module. For example, an input text can go both into a knowledge graph as well as into a text encoder with self-attention and many layers. And they can then go into a fusion layer where text and knowledge fusion is taking place. Left the text and right the knowledge from the knowledge graph, and then lead to text and knowledge output. And we can have here the knowledge graph encoder, a text encoder, and have a joint reasoning layer, a pruning layer, and an answer. And these layers can use basically knowledge graph representations with special attention to knowledge graph elements and to a language model with special attention, and basically mapping here these attention elements also in various ways here to get to better synergies. The name Qualia comes originally from James Pustejovsky for noun semantics. This is about the size of a noun or an object, so what it consists of, its material, weight, parts, compound objects, and so on. And this is the constitutive part, and the formal part, how it is distinguished in the larger domain, orientation, magnitude, shape, dimension, color, and position. And then regarding time, so this is regarding size, regarding time, it can be agentive, have agentive properties about how it was brought about, meaning was created, causal chains, and so on. And dynamic in terms of purpose function called telic. Agent's purpose for an action, built-in functions, aims, and activities. Then Tony Davis from Stanford has added verb semantics with actor, undergoer, figure, ground, effect, means, and accompanying event, and some others. And can then visualize this with the sentence, the seller sells good to the buyer, and the opposite is the recipient receives money from the payer. And so this semantic action is mapped to the semantic roles, actor, undergoer, and endpoint here, with these co-references 1, 2, 3. And these co-references, yeah, they come from those type feature structures or heavy lexicalist approaches like H-driven phrase structure grammar, HPSG, and minimal recursion semantics from Stanford. And they can be mapped here to the syntax of a noun phrase like seller, noun phrase goods, and buyer, the prepositional component. So to the buyer is the prepositional phrase, this complement. So here the word function is subject, object, and complement. And this is a prepositional phrase is syntactic function. So this combines the level of syntax, semantics, and sometimes even pragmatics, and now even large language model elements could come there. This could all be combined in synergy, especially with an LLM PKG mapping and updating in synergies in the space. For example, the semantic points in the knowledge graph can be fixed points for future mappings, so that different LLMs can be mapped regarding semantics. And actually, there's a recent paper in which the various open source LLMs are taken and a better integrated LLM is created from these various neural networks with some fixed point semantics to map them properly on the semantic side or in the vector space. There are also vector databases, as you know. So with semantics and vector space meaning models, one can map these. So on the generated probabilistic knowledge graph side, so we can get that generated because creating it manually is too much effort, and then add additional information like logic, formulae, constraints, rules, functions, world knowledge, 3D physics models, word fields, and elements of planning and so on to improve this. And these can be created semi-automatically, or as one wants, maybe even fully automatically with better AI. So that one can have the best of both worlds of deep learning with sub-symbolic methods and symbolic methods. So, and so algorithms exist for both sides, which can create synergies. And we have less over-generation or under-generation and less nodes leading to hallucinations. So this can be adjusted in both directions. And this PKG can be held explainable and without hallucinations. So then there's more to it. We can leverage everything of thought for them. Then we can all the latest insights of planning, constraints, rules, functions, heuristics, and probabilistic programming. And that can bring about hundreds of synergies, reduce, eliminate hallucinations, confabulations, implement theory of mind, and thus lead with deep reinforcement learning to start to the next level AIs, which can solve much wider sets of problems. Then there's also cause-effect knowledge with modality. So there are many, so these cause-effect dependencies are key to many commercial applications in the sciences, R&D, and diagnosis, for example, of errors in machines. We had a big project with ThyssenKrupp to diagnose reasons for errors, suppliers that have lower quality processes, elements that lead to problems, and so on. One can learn from textbooks this way, and from other descriptions, and then have millions of such details that one can use in the program. We can have modal and temporal relationships, which explains around 99% of all required knowledge for scientists, technicians, especially in support, and they can be visualized quite well. And these can be manually or by another AI be reviewed and fine-tuned, and we can reach very big synergies with other AI techniques with that. Then there's embodied AI, 3D models or metaverse information, plus real-world information, maybe pain and emotion, as we learn as children, so that the AI knows what does a room look like, what does the environment look like. So Jan LeCun recently came out with presentations here, a Google Drive presentation, and a paper on open review with several interesting insights that autoregressive LLMs are doomed. So the next slides are all based on this. So this is a summary basically of this paper and presentation. So they cannot be made factual, non-toxic, and so on, are not controllable. And if you call this tree of correct answers E, then the probability that the entire result is correct is 1 minus e to the power of n. And the bigger n is like with trillions of neurons, it's basically impossible to get it always correct. So this diverges exponentially and it's not fixable without a major redesign. So that was the basis for first thinking about the cognitive architecture about this, to have in the mind, so in the AI mind in this case, a world model, then a short-term memory, an actor model, a perception model, a cost model with intrinsic costs and a critic, and let the actor perform actions on the world, let it perceive what happens in the world, and a configurator to configure all of this with a big focus on costs as compute discomfort. And there I go into the details. So he has here a perception from the world, how it acts on the world model with latent observations, different actions here, guardrail costs and task costs. And interesting here is to use this with objective-driven AI, hierarchical planning. So to have as operation to find an action sequence that minimizes the objective. using, for example, model predictive control. And also promising are gradient-based methods, graph search, dynamic programming, A-star, Monte Carlo tree search, and so on. So this can be formalized like this, like complex networks like these. And you see these can then be efficiently be implemented and scaled into large systems. And I think they're best explained by giving an example. So Jan is thinking how to get sitting from his New York University office to Paris. And then he has the option to go down the street as action, to grab a taxi to an airport. And there are different guardrails. If there are obstacles, hail or call, how bad is the traffic, what's the distance to the airport. Then there are other options. He can take a taxi or a train, choose which airline and so on. And this all comes with costs in terms of time and money and other. His insights are to abandon generative models in favor of joint embedding architecture like JEPA, which I will explain on the following slide, abandon probabilistic models in favor of energy-based models, abandon contrastive methods in favor of regularized methods, abandon reinforcement learning in the favor of model predictive control, and only use reinforcement learning when planning doesn't yield the predicted outcome to adjust the world model or the critic. So a simple description is shown here. So encodings for variable X and Y, then a prediction, and here different predicted outcomes that are being assessed. And also prediction costs and surrogate costs. He then maximizes information content here. The first encoding here also, in the Y encoding, and then has a prediction, and then minimizes information content for the prediction regarding variable Z. So of that latent variable Z, and to minimize the prediction error. So this leads to a mathematical optimization problem where we work here with the covariance and the Euclidean distance and so on of variables. And energy-based models regarding implicit function are, according to Jan Le Cun, the only way to formalize and understand our model types. It gives low energy to compatible pairs of X and Y and gives higher energy to incompatible pairs, and then leads to an energy landscape where we optimize for the minimal Y, which minimizes this entire function depending on X and Y, meaning to find the values in this energy landscape, find the lowest values. Regarding probabilistic models, they are a special case of EBMs, and they can be mapped to each other. EBMs give more flexibility in the choice of the scoring function and also in the choice of objective function for learning. And there are two methods for EBMs, the contrastive method, which basically gives samples, gives positive samples for what's part of the set and what is outside the set, and the regularized method, which defines the boundary of the sets. So here the green arrows define the boundary to learn just what is part of the set. These regularized models are also called architectural methods. So they have these different properties which are relatively complex. It's about pushing down of energy of data points, pushing up of chosen locations, metric learning, Siamese nets, adversarial generators or GANs, masked autoencoders, and using a regularization term that measures the volume of space that has low energy, sparse autoencoders and so on. So it's really technical. I want to skip the rest. It's important to avoid collapse. In this model, there's no collapse. However, these models B to D, they can collapse, and that's important to know and to avoid. Open research topics, so problems to solve are these. And Meta itself is working on these last ones. learning hierarchical planning and object-driven AI architectures, maybe on some others. So these are general research topics. So putting it all together, what Q-star could be, or what could bring us towards AGI and reduce hallucinations. It's a synergistic combinations of all techniques presented above, especially the following ones. So here I'm summarizing them again. Multimodal deep learning, like large language models and multimodal models, to understand with NLP the world. To ideate, and for that hallucinations can be used to come up with new ideas. Also create generative AI, represent figurative understanding and creativity, then graph confidence GNNs, and knowledge graphs, and a synergistic combination of key enabling technology. Whereas here with knowledge graphs, we can also synergistically combine concepts of working memory graph, combinations of the logic syntax world, like bringing head-driven phrase structure grammar and minimal recursion semantics to the next level, represent formal understanding together with formal representations. So and then we can combine this with around planning and everything of thought, chain, tree, graph of thought, MetaGPT or any tool-like systems, retrieval augmented generation, rect chain, length chain, llama index, and so on. We can have transformers encoders and programmed attention that can solve math problems, for example, with Raspberry Flip and Tracer Rasp. We can have improved tech like switch transformers, mixture of expert models. We can use the best systems in their domains, possibly computer algebra systems, KL1 systems like Loom, AlphaFold, compiler ecosystems, CAD systems, and so on. Knowledge representation with the KISS and plugin principle. We can optimize for creativity, the transfer of ideas, principles, and so on. Have agentive large language models controlling the knowledge, and maybe source code implementations to auto-optimize and extend them. And then we could have nonlinear planning, while linear planning is constrained. Nonlinear planning is basically flexible in all directions regarding sequences, subgraphs, falling in between, and then restarting or partially restarting, assessing the outcomes if plans were executed, for example, in the Q-star manner. Analogical reasoning, transferring of ideas and principles from one domain to the next. Genetic algorithms, evolutionary AI's critique, and exchange of ideas, elements, components, or genetic strains with others, or with simplification, or more advanced concepts, and then assessing again. Possibly a plug-in principle for various knowledge domains like logic components, data science, and specialty domains like chemistry, biology, and so on. And then various databases for SQL, NoSQL embeddings, the vector DBs, and so on. Episodic memory for consistent stories, logic, principles, heuristics, and patterns. Synthetic data, semi-self-supervised learning, optimizations like long LLM lingua, low-range adaptation, and so on for training. Maybe later, various improvements like liquid neural networks, capsule networks, hierarchical technical memory, GC forest, QLatities, RIMs, and so on. And maybe the ability to self-modify and improve smart visualizations, and taking integrations and knowledge from all five tribes: symbolists, Bayesians, connectionists, evolutionists, and analogizers. In the future, we will probably all have universal virtual assistants. The question is who controls them, and also the question of how ethically does an AI behave is less about the AI, especially so far. It's more about who controls the AI. And if one or a few evil billionaires control the AI, then we might be doomed as humanity. So we really must, to survive as free humans, have an open source free AI with a repository of all human knowledge and culture, linguistic, cultural, have various interest groups participate, a shared infrastructure like the internet today, and condensing all science and human knowledge with guardrails, but without censorship. Otherwise, our culture will be controlled like by a few companies on the west coast of the US or in China. And thus the training of them should be modular and crowdsourced, so also to overcome catastrophic forgetting. Therefore, open source AI platforms are necessary. They must not be regulated out of affordable existence. So that is the opportunity for an open source platform for AI and a global strategy for the good of humanity. So we propose an open extensible plugin architecture that could facilitate the following: collaborative, ethical creation and co-creation, curation, curation training, monitoring and benefiting from AIs, personalized AI-based coaching, mentoring, for example, for transcending negative feelings, for personality development, e-learning, and so on. Efficient cooperation and teamwork with smart material review and visualization, finding the most efficient and promising solutions, for example, for the green transition and other hydrogen technology. Healthcare, then have discussions, negotiations, voting around possible trade-offs, avoid mass unemployment, cataclysms, and misery by finding the optimal strategies. And to my knowledge, only Potentialism or PerConFlow has several solutions to this. The details can be found here. And so we are part of that team. And by amplifying human intelligence, I can bring a new era of enlightenment, if it's not monopolized by evil billionaires, and a new renaissance for humanity. The architecture of the system could look like this. So having a persistence layer here with various databases, all of this virtualized. So also episodic memory and maybe open search to store vector spaces as vector DB, and then a middleware with a central controller or AI something, so processors to check consistency, machine learning, and so on. Unification of knowledge, a core universal knowledge representation, an in-memory data grid, a messaging system, model drift adaptation, knowledge representation, extensions, so all of this as a plug-in system, smart visualizations, scenario modeling, possibly coaching and giving advice, speech, thanks to this Qualia Crystal-like systems. So these key elements that have explained, explainable AI, APIs, and so on. You could have a search technology here with possibly Apache Drill and drill bits, the user interfaces, and monitoring also front ends with various plugins, especially for, say, chemistry, infographics, 2D, 3D structures, and so on, knowledge editors or visualizers, and here various AIs. For example, here we have classical AI like probabilistic technologies, logic, symbolic reasoning, constraints, nonlinear planning, rule systems, then simulation technology to simulate the world, basically, or what would happen in the model domain. Then we have LLMs, and we would try to improve them. Here, orchestration training environment, and semi-self supervised fine training, rec training, length training, and so on. We could have then the next level, retrieval augmented generation, low range adaptation, LoRa. And so there we would have typically a generator, LLM or LMM, transformers, knowledge graphs, retriever, parsing, chunking, filtering, and rating. So these are these 5 lower ones are even today the key components in LLMs. Then also knowledge graphs, agents like MetaGPT and external APIs. And then we could have the classical data science stack, like with Apache Spark, scikit-learn, and so on, open scoring, XGBoost, graph confidence, and then the PyTorch stack, which is the best current deep learning stack. Yeah, and then just some basic information about reinforcement learning. There we have really many models, and many algorithms. They typically come from gameplay, and there's also different frameworks for them. And they also They're typically trained with RLAIF, AI feedback. So there are techniques to avoid reward hacking. And then we have Deep South, the computer simulating an anti-human brain. It's an interesting project. So the simple solution for AI safety is to apply latest cybersecurity and security constraints, not telling the AI about assembler programming and hacking, and not allowing the AI to self-modify so that it cannot escape. Then it basically cannot hack itself and cannot hack others. And then it's relatively safe. So AGI could possibly even run the government. And a satire, how do you create an AGI? You create a company with a goal to construct an AGI, then build up rumors about a mysterious model Q star, which got close to AGI, and then let the entire internet community speculate how that quasi AGI was achieved, implement the most promising speculations, and turn on your AGI. And that could be what's behind what you've seen. So we as a company have been consulting these customers and many more, especially in finance, health, transport, e-commerce, and other tech. We've positively impacted around 1 billion people, as you can see here in various domains. I myself have 8 granted software patents. And you can accelerate your AI AGI journey with our top consulting. We have 10,000 contacts in the USA and the EU, 20 years experience, and you can reach me as thomas@potter.org or on LinkedIn, and also on X. I have 8 granted patents, 2 fair highlights, and so on, 20 years AI experience. So thank you very much and have a great day. Bye-bye.